Okay, how are you, everyone? This is Dr. Elsharafi. I'm going to talk about the effect of the laminar and turbulent flow on the phase change materials for energy recovery, which is going to be for UGRU 2022. And this is my contact information here. Please don't hesitate and send me email or call me in my phone number if you have any questions. I'm going to talk about the laminar and turbulent flow, and also going to talk about the project FOX, which is improved thermal energy storage, which is renewable energy. And we will talk about phase change material. We talk about our unit and design. And also we talk about how the unit is going to work, circulation measurement, fluid, and paraffin wax, which we're going to use, and also thermocouples, which we're going to use to measure temperature. Our objective for this work is to determine energy and the power generation generated by the phase change materials. What's the laminar and turbulent flow? Laminar flow is a smooth flow, and the turbulent flow is not a stable flow, and this is affected by the properties of the fluid inside the piping system. And this is according to the Reynolds numbers, which are going to determine the laminar flow and turbulent flow. If our Reynolds numbers is less or equal to 2,300, that means we have a laminar flow. If it's more than 3,000, that will be a Reynolds numbers. If something is between, that would be a transition zone. And there is a formula that we can use to calculate Reynolds numbers, which is the ratio between the internal force to the viscous force, which is a function of the diameter of the pipe, velocity of the fluid, density of the fluid, and viscosity of the fluid. Phase change material is a material that we're going to use. We're going to use paraffin, and also we might use the solid. We might use the salt, which is a solid materials, which going to be used to absorb the heat from the hot water, which we're going to use for turbulent flow, and we're going to use also viscous mineral oil for laminar flow. It's laminar flow because the viscosity of the oil is high compared with water. We will use the paraffin wax, as I said, and also we determine, the temperature of the melting wax. It's going to be about 58. That means we're going to use the temperature is about 60 to melt the wax. Salt is very hard to use because the melting temperature is going to be very high. That's a concept of the thermal energy storage. It's a function of the temperatures, which is we're going to start with the heating the wax by using hot water. We will start storage heat, as you can see in A, which is a sensible heat, and then we're going to have a latent heat that's start melting the wax until we melt the wax is 100% is melting the wax. Then we start having sensible again, and then we circulate the cold water. The cold water is gonna make a solidification of the wax. That's our unit, which we're gonna use. Actually, we got the plates from the Toronto company. It's a local company. We use in our work, and also we use a chamber plexiglass in the back. We put the wax in that chamber, and then we circulate the hot water to melt the wax, and then we circulate the cold water to absorb the wax. We use the different thermocouples to measure the temperatures around our system. We have a data acquisition also to monitor the pressure and temperatures through our system. We use the lab view for our experiment to measure the data that we need to get from this work, and also we use the USB carrier connected to the thermocouples and then connected to the data acquisition system. That's the CAD modeling, which we use. As I said, we use the blades, plexiglass, and we use the gasket to prevent our modeling and unit from leaking. Paraffin temperatures, first function of time. We start, at 0. This experiment takes about almost 200 minutes, and we start having, the sensible heat we melting the wax, then until we reach, we start sensible heat until we reach, the wax start melting here for the latent heat, and then we start having, liquid, which is a sensible heat. Again, we increase, the temperature until we got, the sensible heat, which we start, getting the solidifications, and the melting is gonna convert to the solid by circulation of the cold water. And for this work also, we're gonna calculate the total energy storage, and we calculate the power recovery by using, those formula here to calculate, the total energy storage as a function of the latent heat and also as a function of the sensible heat. And we know that the properties of the paraffins also is giving, such as the melting point, a specific heat, latent heat, the mass, thickness of the plates, thermal conductivity, and also the effective area of the wax, which we need to find out the power recovery as well as the total energy recovery. And thank you so much. If you have any question, please don't hesitate to send me. And by this, I will end the presentation, and I will wait your questions. Thank you so much.